You know that feeling, maybe you're in South Florida, maybe you're just somewhere
Yeah.
incredibly reliant on modern life. You
Mm.
turn on the tap, the lights come on, the air conditioning hums. It's the energy that powers everything.
Yeah.
But what if that essential power source, that underlying hum, is woven into a complex and maybe potentially precarious relationship with the very water you drink
Hmm.
and the unique, wild places that define a region?
That interconnectedness is absolutely fundamental. And in a place like South Florida, I mean, water defines the landscape, right? It sustains millions of people. So the systems we build, even vital ones like power plants,
Yeah.
they exist within an incredibly delicate environmental balance.
Yeah.
And when that balance gets strained, well, the implications can be huge, really
Yeah.
far-reaching.
Exactly. And that delicate balance, specifically in the context of an aging power facility in South Florida,
Hmm.
is precisely what we're focusing on today on Meteorology Matters. We've been digging into information that presents a really detailed look at the Turkey Point nuclear power plant.
Yeah.
Its history, its unique geographical setting, its cooling system, and the significant environmental questions that have arisen, especially as we grapple with changing weather patterns and a shifting climate.
Yeah, the material we've looked at, it sort of lays out concerns raised by various environmental and community groups. And then you see the responses and actions from the plant's operator kind of juxtaposed against that. It really hones in on the intersection of the facility's physical footprint, its operational needs, and the natural environment it occupies. And particularly, decisions about the plant's lifespan come up a lot.
Our aim for this Meteorology Matters discussion, for you listening, is to move beyond just a surface understanding. We want to pull out the crucial details, understand the different perspectives, and really grasp what's truly at stake here, both for the immediate environment and for the millions of people who call this region home.
Yeah, getting informed quickly and thoroughly, it's complex stuff.
It is. So let's get started by looking at the plant itself and where it sits.
Right. So the facility in question is the Turkey Point Nuclear Power Plant. It's located way down in South Miami-Dade County, a part of Florida just known for its unique geography.
Mm-hmm.
Construction on the plant began way back in the 1960s, and it first started operating in 1967.
1967. Wow. Just to put that in perspective, that makes it one of the earliest nuclear power facilities built in the United States.
Yeah, one of the real early ones.
Which means it's now one of the oldest still in active operation today. And for decades, it's been a major power source for a vast urban area, right? Providing electricity to power, a huge number of homes and businesses.
The estimates are around 3 million people served, or roughly a million residential and commercial customers. So yeah, a big provider.
Yeah, and its location, like you said, is absolutely central to this whole story.
Totally. It occupies a significant piece of low-lying coastal land. On one side, you've got the vibrant marine ecosystem of Biscayne Bay. A national park actually starts just a few miles away.
Right.
And then to the west lies the vast, complex freshwater wilderness of the Everglades. Plus, it's situated pretty close to the sensitive ecosystems of the Florida Keys.
But the geology, the water situation underneath it all, that's maybe the most critical piece, isn't it?
I'd say so. The plant sits directly on top of the Biscayne Aquifer. And this isn't just, some underground pool.
Yeah.
It's the primary vital source of drinking water for millions of people across South Florida.
So you have this large, aging industrial facility built decades ago, sitting right on the coastline, positioned directly above the main water supply for a massive metropolitan area. That setup alone raises questions.
It does, and the operational necessity that creates a unique challenge at the specific site is the cooling system required for the nuclear reactors.
Okay.
Unlike many, maybe more recent, nuclear plants that use those towering structures you often see, releasing steam high into the air.
Yeah, the cooling towers.
Right. Turkey Point uses a different approach. It relies on this expansive network of open cooling canals.
Open canals, how big are we talking?
This system is massive. It stretches out over 168 miles through the surrounding landscape.
168 miles of canals. That's incredible. It's a huge footprint. You can really picture it's just spread out like a giant, intricate network.
Like a massive ground-level radiator, basically. That's a good way to visualize it. Just dissipating the heat generated by the reactors out into the environment.
But it wasn't always canals, was it? What was the original plan?
The initial cooling system, before the canals were built, actually discharged heated water directly into Biscayne Bay.
And that had consequences, right?
Oh.
I imagine dumping hot water into a sensitive bay isn't ideal.
Not at all. Significant consequences. The introduction of all that heated water into the bay's ecosystem caused considerable environmental damage. You know, harming marine life, changing the local ecology.
So what happened?
It led to legal challenges, specifically a lawsuit filed way back in the early 1970s. And the outcome of that lawsuit mandated that the plant operator, FPL, stop discharging into the bay. And instead, they were required to construct this extensive canal system through the adjacent wetlands to handle the cooling water.
So this massive canal system we see today was actually a direct result of needing to fix environmental damage somewhere else.
Yeah.
But building it through wetlands, that sounds like it could introduce a new set of issues.
Exactly. Perhaps unforeseen challenges at the time.
How does this closed-loop canal system even work? And
Yeah.
what's the fundamental problem that arises from it being open to the South Florida environment?
Well, the design is pretty simple in principle. Water is drawn from and returned to the canals. It circulates to cool the plant. The system gets replenished mainly by rainfall.
Okay.
And naturally, the water in this coastal region contains trace amounts of salt just normally.
Right.
The critical issue is the climate. South Florida is hot. It's sunny. That intense sun causes a tremendous amount of water to evaporate from the open surface of these canals every single day.
How much water are we talking?
We're talking about an estimated 30 to 40 million gallons per day just evaporating into the atmosphere.
30 to 40 million gallons
Mm.
daily, just vanishing into the air because the system is open like that. That's hard to even wrap your head around.
It is a staggering volume of water loss. And here's the really crucial part. When water evaporates, the salt that was dissolved in it, it gets left behind.
Ah, okay. I see where this is going.
Yeah. Over time, this continuous evaporation process causes the salt concentration in the remaining canal water to just rise dramatically. The water becomes increasingly salty or hypersaline, much, much saltier than typical seawater.
Hypersaline.
And because these canals are unlined, they weren't built with, like, concrete bottoms or anything.
Just dug into the ground?
Pretty much. And the geological foundation of South Florida is porous limestone bedrock. It's like a big sponge underground.
Right.
So this hypersaline water doesn't just stay put in the canals. It leaches downwards and outwards, seeping into the underlying Biscayne aquifer.
Okay, so the fundamental problem isn't just the heat that's what requires the cooling in the first place. It's the design of the cooling system, these open, unlined canals, combined with the hot climate. That leads to super salty water that then leaks straight into the drinking water aquifer.
Precisely. And that leakage creates what's been termed a hypersaline plume.
A plume. Describe that. What is it exactly?
It's essentially this mass, this sort of blob of that super salty water originating from the canal system, migrating, spreading through the porous underground aquifer.
Just salty water, or is there anything else in it?
Well, adding another layer of concern, the material mentions that monitoring has shown this plume also contains trace amounts of radioactive isotopes.
Radioactive isotopes.
Yes.
Like what? Tritium is specifically mentioned in the sources we look
Hey,
at.
Jim, okay, what is that? Tritium is basically a radioactive form of hydrogen. It's actually often used in hydrological studies precisely because it follows the movement of water really well. So its presence confirms that the water from the canals, containing substances from the plant's operation, however trace, is indeed migrating out into the aquifer.
So this plume of salty tritium-laced water is on the move underground. Where is it headed? And what's the direct threat it poses?
It's been spreading primarily north and west within the aquifer.
North and west.
Yeah, and this direction of movement is particularly concerning because it's heading towards the region's public drinking water wells.
Oh, wow.
Okay.
Maps and monitoring data show this documented spread. It clearly indicates the plume has extended well beyond the original perimeter of the cooling canal system itself.
So it's not contained within the boundaries of the plant property or even just right under the canals. It's actually spreading out into the aquifer that serves millions of people. How close has it gotten to the actual drinking water sources?
The information we reviewed provides some specific distances that really underscore the proximity and, the potential threat. The plume has been detected within 4 miles of one of Miami's public well fields.
4 miles. That sounds close.
It is uncomfortably close, and perhaps even more significantly for a whole other community, it's roughly 7 miles from the main water wells and the treatment plant that supply drinking water to the entire Florida Keys.
7 miles to the Keys water supply. In a car, that's nothing, but underground moving slowly through porous rock. Yeah, that's way too close for comfort to the only source of drinking water for that entire chain of islands.
Excellent.
What are the actual consequences if this salty plume reaches those wells and mixes with the freshwater supply?
Well, the primary and most severe consequence is pretty simple. The water could become too salty to use,
Undrinkable.
completely undrinkable without extremely expensive and energy-intensive desalination processes. It also makes it unsuitable for irrigation, which impacts any local agriculture, and it can seriously harm freshwater ecosystems that rely on that aquifer water seeping out.
And the Florida Keys Aqueduct Authority, the folks who provide water to the Keys, they rely on those wells near Turkey Point.
They do, and we're told they are undertaking this massive $100 million overhaul of their water treatment plant right now.
$100 million.
Yes. And a significant part of that huge investment is specifically aimed at being able to potentially handle increased salt levels in their source water. They are directly preparing for the possibility of this plume eventually reaching their wells.
Wow. $100 million being spent just to prepare for potential salt intrusion from this plume. That figure alone tells you how serious this threat is perceived to be by the people actually responsible for providing drinking water down there.
It absolutely does. It's a concrete, real-world cost directly associated with the environmental impact of this cooling system.
And it's worth saying again, this isn't some hypothetical future problem, is it? This plume has been an issue for a while.
Exactly. It's not brand new. Even before 2015, official findings from Miami-Dade County in the state of Florida determined that the plant owner, Florida Power and Light FPL, which is a subsidiary of Nextera Energy, Inc., was actually in violation of water quality laws.
They were already breaking the rules. Why?
Because the plume had already migrated beyond the regulatory boundaries that were supposed to contain it around the canal perimeter. The problem was already happening, documented, and causing violations years ago.
Okay, so the documented violations finally prompted some action, which brings us to the efforts that have been made to try and contain this plume, right?
Yes, exactly. Following those regulatory findings and the legal agreement that was hammered out in 2015, FPL committed to implementing a remediation plan.
Okay, a plan. What was the goal?
The core objective of this agreement was pretty ambitious: to dramatically reduce the size of the hypersaline plume and pull it back within the boundaries of the cooling canal system by the year 2028.
By 2028. Okay, and what system did they actually put in place to try and achieve this pullback?
It's kind of a multi-part pumping system designed to manipulate the flow of water underground. What they did was drill 10 wells, primarily located along the western edge of the canal system, the side closest to the Everglades and those drinking water wells.
Okay, 10 wells. What do they do?
These wells function essentially like giant underground straws. They're actively pumping the salty plume water out of the aquifer at a rate of about 15 million gallons per day.
15 million gallons of salty water pulled out every day.
Right. The idea is to create what's called a hydraulic barrier, or maybe think of it as a sink, to sort of suck the plume back towards the canals and stop it spreading further west.
Okay, so they're extracting the salty plume water, 15 million gallons a day. Where does all that water go? They can't just dump it somewhere else, can they?
No, definitely not. The water that's pumped out, remember, it contains those trace amounts of tritium and obviously very high salt levels. It isn't just released back into the environment near the surface. It gets injected thousands of feet underground.
How deep?
They send it down approximately 3,200 feet deep into a geological formation that's often referred to as the Boulder Zone.
The Boulder Zone, what's that?
It's described as this cavernous layer really deep beneath the surface. And the belief held by FPL and the regulators who approve this is that at that depth, the injected water and any associated contaminants are safely contained and won't pose a risk to the shallower drinking water sources or the surface environment, sort of locking it away deep underground.
Pump the salty water out, send it way, way down deep into the Boulder Zone. Is that the entirety of the system, or is there more to it?
No, there's another pretty significant component to try and manage the salt concentration within the cooling canals themselves. And also just to make sure there's enough water circulating for cooling, they also pump water into the canals.
Okay, where does that water come from?
They draw about 30 million gallons per day of less salty, kind of brackish water from wells drilled roughly 1,000 feet underground, so shallower than the injection zone, but deeper than the aquifer.
Right.
This brackish water is then added directly to the cooling canal system. The goal is twofold: dilute the really high salt levels in the canals and just keep the canals topped up because of all that evaporation.
So let me get this straight. It's a two-pronged approach. Pump, 15 million gallons of super salty plume water out and inject it deep underground while simultaneously pumping 30 million gallons of less salty, brackish water into the canals to dilute and replenish.
That's the essence of it.
That sounds like a pretty substantial engineering effort, a lot of water moving around. However, the information we reviewed also includes some serious critiques and concerns about whether this approach is actually effective or if it's really solving the core problem.
That's right. There are definitely counter-arguments.
What are the main arguments against this system fully fixing the plume issue?
Well, the primary critique, the one that comes up again and again, is that while the pumping system is designed to shrink the plume by extracting water and trying to influence its movement underground, it doesn't actually address the fundamental issue causing the plume in the first place.
Which is?
The fact that the canals are unlined and continue to leak hypersaline water into the aquifer day after day, critics argue this whole pumping system is basically treating the symptom, the migrating plume, rather than the root cause, the leaky canals themselves.
So the leaky canals are still the source of the problem, the contamination, and the pumping system is just trying to manage the consequences of that ongoing leak, rather than stopping the leak itself.
That's the core argument, yes. And it gets potentially more complicated. A study published back in 2016 by David Chin, who's a professor at the University of Miami.
Okay, what did his study find?
He specifically highlighted a potential and potentially serious unintended consequence of the remediation system. He suggested that adding the lower salinity brackish water into the canals, while it's meant to dilute the salt.
Right, that sounds like a good thing.
You'd think so. But his analysis suggested it could actually raise the overall water level within the cooling canal system. And a higher water level in these unlined canals, sitting directly on top of that porous limestone rock, could potentially increase the pressure and therefore the rate of leakage from the canals into the aquifer. So it could actually be exacerbating the very problem it's partly meant to mitigate, making the leaks worse.
Wow. That's a really critical concern, that a measure intended to help dilute the salt could, in fact, be worsening the underlying leakage that created the plume in the first place. That seems counterproductive.
Exactly. And engineering news reports from around that same time, like one by Thomas Armistead in 2016, seem to support this general concern. His reporting suggested that the leakage from the cooling canal system itself appeared to be the major factor driving the plume's continued westward movement, even with all the pumping going on.
So there are credible scientific and engineering concerns that the system, while active in moving a lot of water, might not fully address the root problem, and could even have some counterproductive effects on the rate of leakage itself. How is the progress reported then towards that original 2028 containment deadline? Did it work?
Well, FPL reported a couple of years ago that, based on their progress, they would not be able to meet the 2028 deadline that was stipulated in that 2015 agreement. They wouldn't fully contain the plume within the canal boundaries by then.
Okay, so they acknowledged the deadline would be missed.
Yes. However, they also claim significant progress has been made because of the pumping system. An FPL spokesperson, Bill Orlov, is quoted stating that the pumping efforts have already reduced the plume size by almost half.
Almost half. That sounds like progress.
And that they've successfully cut salt levels within the plume, bringing it closer to the canal boundaries, moving towards compliance with the regulatory orders, even if the final deadline won't be met on time.
So, a missed deadline acknowledged, but also claims of substantial progress in shrinking the plume and reducing its saltiness. What's the regulatory perspective on this? What does the county say?
Wilbur Mayorga, who is the environmental chief for Miami-Dade County, confirms that FPL is indeed required to make modifications to the system because the 2028 deadline won't be met.
Okay, so changes are needed.
He emphasizes that these modifications require county approval and rigorous verification. They need proof to ensure they are effective in achieving the necessary plume retraction over time. They can't just take FPL's word for it.
Makes sense.
And you also have Mary Jo Hernandez, who's an FPL environmental specialist, quoted. She notes the sheer volume of water extracted, over 30 billion gallons of salty water pulled out so far. And she expresses that she feels progress has been made and finds the work rewarding.
30 billion gallons. That's a lot of water moved. It sounds like a situation where the initial fix wasn't sufficient. It requires ongoing tweaking and modification, constant regulatory oversight, even while FPL points to some positive results from their efforts so far. Are they looking at completely different ways to tackle the plume now that the deadline is slipping?
Yes, the material mentions that there are ongoing discussions about considering new or modified strategies. One specific option being discussed is the possibility of drilling horizontal wells.
Horizontal wells. How would that work differently?
The idea behind that approach is to try and intercept and extract salty water that has potentially migrated further west, maybe spread out thinner, than the current vertical wells can effectively reach. Essentially trying to capture the parts of the plume that have crept closest to the potable water supply wells.
Okay, so still pumping, but maybe a different configuration to get at the water that's spread out further.
Possibly, yeah. It's one idea being floated.
So the plume issue persists, the efforts to contain it are ongoing, and face these critiques, the 2028 deadline won't be met. But this aging plant and its environmental challenges, they exist within a broader context of increasing risks, don't they? Which leads us to think about the impacts of climate change.
This is where the situation gets, even more complex and pressing. The problem of the hypersaline plume isn't occurring in isolation. It's happening at a site facing other major threats.
Like what?
A recent report from 2024 by the Government Accountability Office, the GAO specifically identified Turkey Point as one of 15 nuclear plants in the entire United States that are significantly exposed to major hurricanes, storm surge, and flooding.
15 plants facing those risks.
And critically, the GAO report highlights that these natural hazards are expected to be exacerbated, basically made more severe and more frequent by climate change.
So a location that's already vulnerable to intense South Florida weather is becoming more vulnerable because of climate change, and it happens to house an aging nuclear power plant. Let's talk a bit more about that age factor again.
As we noted, Turkey Point started operating way back in 1967. This places it firmly among the earliest generation of commercial nuclear reactors built in the U.S.
Right.
There are currently over 90 operating reactors in the country, and the average age is now over 40 years old. So Turkey Point is well above average in age.
And when we look at the history of nuclear power, Turkey Point is older than some facilities that have faced, well, major incidents, isn't it?
It is, yeah. It's older than the 3 Mile Island plant in Pennsylvania, which experienced that partial meltdown in 1979, still the most serious nuclear accident in U.S. history.
Older than 3 Mile Island.
And it's also older than the Chernobyl plant in Ukraine, site of the catastrophic accident in 1986.
Older than Chernobyl, too. And perhaps most relevant, given its location and the climate risks we're talking about.
The sources we looked at draw a direct and quite stark comparison to the Fukushima Daiichi plant in Japan.
Fukushima, right, the 2011 disaster.
Exactly. Both plants, Turkey Point and Fukushima, are of similar age, built in the late 1960s, early 1970s. Both are situated right on a coastline. The disaster at Fukushima was triggered by that massive earthquake and the subsequent tsunami. But the critical factor that led to the meltdowns there was the inundation by seawater. The flooding disabled the essential cooling systems.
Okay, I see the parallel.
Yeah, this comparison really illustrates the potential vulnerability of coastal nuclear facilities to extreme water-related events, storm surge, flooding, tsunamis. Risks that climate change is widely projected to intensify globally, and certainly in specific regions like low-lying South Florida.
So the specific climate threats highlighted in the material as relevant to Turkey Point are these powerful storms, more widespread flooding, definite sea level rise in that area, increased drought risk potentially affecting water levels, and also rising temperatures, just general heat stress. How does the plant owner, FPL, respond to these clear climate-related vulnerabilities and the concerns being raised?
Well, FPL emphasizes the plant's robust design and the significant investments they've made over the years to harden it. They state that the most critical structures, including the reactor cores themselves, were constructed atop 20-foot-high mounds.
20 feet high?
Yeah. They maintain this elevation is sufficient to withstand storm surge levels higher than any recorded in South Florida's history.
And they often point to their experience with a specific, very major storm, don't they?
They do. They frequently cite Hurricane Andrew back in 1992. This was a Category 5 hurricane, one of the most powerful ever to make landfall in the U.S., and it passed directly over the Turkey Point site.
A direct hit from a Cat 5.
Yes. And FPL states that the plant's critical infrastructure was undamaged by that direct hit. They present this as compelling evidence of its inherent resilience to extreme weather.
Okay.
The FPL spokesperson, Bill Orlov, is quoted reiterating that safety is paramount, it's their cornerstone, and that their plants are designed to withstand natural events exceeding the strongest ever recorded in their specific locations.
And beyond just the initial design and surviving, Andrew, they talk about ongoing preparations and upgrades too.
Absolutely. FPL highlights substantial ongoing investments in hardening and upgrading the plant. They state they've invested over $2 billion with a B in enhancements to the nuclear units just over the past decade.
$2 billion.
Plus, they invest millions more during planned refueling outages, which happen periodically, for continuous upgrades. These include things like specific fortifications against extreme weather, encasing critical equipment in reinforced steel and concrete barriers. They also talk about enhancing cooling system reliability with features like high-capacity backup pumps to provide cooling water for safety systems, and the capability to shut down the plant safely within seconds if an emergency situation arises.
Because I feel they are prepared.
They also mention in integrating the nuclear output with other clean energy sources they operate nearby, like solar farms and battery storage systems.
Okay, so FPL's position seems clear. The plant was well designed from the start, it proved resilient in a monster hurricane, and is continuously being upgraded and fortified to handle future risks, including those related to climate impacts. What do the environmental advocates say in response to all this? Do they buy it?
They acknowledge the investments FPL has made, but they continue to raise serious concerns about the potential catastrophic consequences of any serious incident at a facility located so close to major population centers.
The location again.
Yes. Rachel Silverstein, who's the CEO of Miami Waterkeeper, is quoted specifically highlighting this proximity to millions of people. She emphasizes the sheer scale of the potential impact if something were to go terribly wrong.
Right.
Their argument, as articulated by Silverstein and others from groups like Friends of the Earth and NRDC, isn't necessarily framed as being anti-nuclear power in general. They stress their position is one of advocating for rigorous safety standards, comprehensive risk assessment that fully accounts for climate change, and ensuring that if nuclear power is going to be part of a low-carbon future,
Which many people argue it needs to be.
right, then these aging facilities, especially those in vulnerable locations, must be unequivocally able to withstand the very real and intensifying risks posed by climate change, including more powerful storms, higher storm surge due to sea level rise, and increased flooding potential. They want clear-eyed risk assessment and proof of resilience.
It's such a crucial point in the broader energy conversation, isn't it? Can our existing nuclear infrastructure reliably serve as a climate solution if it is itself increasingly vulnerable to a changing climate?
That's the core tension.
And this whole discussion about safety, climate risk, and the plant's age is directly linked to these fundamental decisions being made about how long this plant will actually be allowed to operate.
Which moves us neatly into the regulatory process and the whole question of plant longevity.
Exactly. This is where a really significant regulatory decision comes into play. The National Oceanic and Atmospheric Administration, NOAA, essentially, but technically the NRC, the Nuclear Regulatory Commission, is the agency here.
Oh, okay, the NRC. Good clarification. Right, the NRC, the federal agency responsible for regulating nuclear power plants in the U.S., made a decision regarding Turkey Point's operating license. They approved an extension.
An extension.
For how long?
An extension that would allow the plant to continue running for decades beyond its original intended lifespan. Specifically, this approval permits one of the Turkey Point units to operate until 2053 and the other unit until 2052.
2053, wow. That's well into the future. That's pushing the plant towards operating for an incredibly long time. And the material we looked at notes something pretty unprecedented about this particular extension application, right?
Yes, it does. Turkey Point was the very first nuclear reactor in the United States to apply for and initially receive approval to operate for a total of 80 years.
80 years. Has that ever been done before?
No. This is truly historic within the industry. No nuclear power plant anywhere in the world has ever operated for that long. The context here is that many U.S. plants from that early 1970s era are now reaching the end of their initial 40-year licenses.
And many are applying for and receiving their first 20-year extensions, which takes them out to 60 years of operation.
60 years seems pretty standard now for extensions.
It's becoming more common, yes. But Turkey Point went further. They sought and initially received approval for a second 20-year extension, bringing the total potential operating life up to 80 years.
Why push for 80?
Well, it reflects a broader interest, both from industry and policymakers, in leveraging these existing nuclear assets for low-carbon energy production. Given the huge challenges and costs associated with building brand-new nuclear plants, extending the life of existing ones is seen as a potentially quicker and cheaper way to maintain zero-carbon electricity generation.
Okay, so Turkey Point is essentially pioneering the concept of an 80-year operational lifespan for a nuclear reactor in the U.S. Who is challenging this decision to let it run that long?
A coalition of environmental groups and also the Miccosukee tribe of Indians of Florida have actively opposed this 80-year extension. Groups including Miami Waterkeeper, Friends of the Earth, the Natural Resources Defense Council, and the Miccosukee tribe have legally challenged the NRC's decision.
What are their primary arguments against allowing this specific plant in this specific vulnerable location to operate for potentially 80 years? What are the grounds for the challenge?
They raise several key points based on the information they've gathered and presented in their legal filings. One major argument is that they contend the NRC failed to adequately consider and account for that crucial report from the Government Accountability Office we mentioned earlier.
The GAO report on climate risks.
Exactly. That report, published just this year in 2024, explicitly stated that climate change is projected to worsen the natural hazards like hurricanes, storm surge, flooding that pose risks specifically to Turkey Point. The critics argue that overlooking or downplaying this climate risk assessment from a government watchdog body was a fundamental flaw in the license extension review process.
So essentially, they're arguing that the regulators didn't properly factor in the increasing climate risks that government experts themselves highlighted for this plant. What other points do they make?
They also point to specific operational incidents that they argue raise concerns about the plant's ability to handle heat and stress, which is particularly relevant in a warming climate. They cite an incident back in 2014 where FPL's cooling water in the canals exceeded the then acceptable temperature limit. It got hotter than 100 degrees Fahrenheit.
Okay, it got too hot. What happened?
Well, the groups argue that instead of issuing a citation or some kind of penalty for exceeding the temperature limit, the NRC's response was to simply raise the acceptable temperature limit for the cooling canals to 104 degrees Fahrenheit.
They just raised the limit.
Yeah, that's the argument, yes. Effectively allowing the plant to operate at temperatures it had previously exceeded. The groups contend this reflects a regulatory failure and maybe a troubling pattern of adapting the rules to fit the reality, rather than addressing the operational strain itself, especially strain that's likely exacerbated by rising ambient air and water temperatures due to climate change.
That incident certainly sounds like it reinforces their concerns about the plant's vulnerability to heat, which climate change is only going to make worse over the coming decades. Are there other arguments related to the fundamental question of age and just how long these machines can realistically last?
Yes, absolutely. The environmental groups and watchdogs also challenge the whole premise that these plants can safely and reliably operate for 80 years. They argue that the real-world operational lifespan of many nuclear plants has actually proven to be much shorter in practice.
Oh, so.
They cite data indicating that among the U.S. nuclear plants built before 1973, so the same generation as Turkey Point, roughly half of them were actually decommissioned within 40 years of beginning operation. Not 60, not 80, but 40.
Half of them shut down within 40 years. Why?
They specifically quote the Seacoast Anti-Pollution League, an organization that tracks this, which stated that these plants were often shut down within that 40-year time frame because they, quote, simply wore out, broke down, or never functioned properly.
Wow.
This historical data, the groups argue, suggests that pushing plants like Turkey Point towards 80 years might be attempting to exceed their practical, safe operating limits based on how this specific generation of technology has performed historically across the fleet.
So the debate over the 80-year extension involves not just the plant-specific location and the increasing climate risks there, but also this fundamental disagreement about the reliability and the actual expected lifespan of this aging technology itself. How has this legal and regulatory challenge actually unfolded over time? It sounds complicated.
It has been a multi-year process, definitely, with several back-and-forth decisions. The NRC initially approved the 80-year license extension for Turkey Point back in 2019.
Okay, approved in 2019.
But the coalition of advocacy groups immediately challenged that decision legally. Their core arguments centered on the claim that FPL had not adequately demonstrated how the plant would cope with the projected impacts of climate change over such a long, extended lifespan. And crucially, they argued FPL hadn't presented a viable, guaranteed plan to fully clean up the existing hypersaline plume that was already threatening the drinking water supply.
So the challenge was based on climate preparedness and the existing plume problem. Did that challenge have an effect?
It did. In 2022, in response to the legal challenge, the NRC actually ordered FPL to conduct a new, more comprehensive environmental impact study, specifically addressing those points. This action effectively put the 80-year license extension on hold while this additional study was completed and reviewed by the agency.
Okay, so a pause for more study. What happened after the new study?
Well, in 2024, earlier this year, following the submission and review of FPL's reapplication and the new environmental study, the NRC again approved the license extension. They reaffirmed their decision, allowing the plant to operate until 2052 and 2053.
So, after a period of deeper review and a new study, the extension was reapproved by the regulators. What is the current status of the challenge now? Is it over?
No, not yet. Miami Waterkeeper is currently appealing that 2024 decision by the NRC.
They're appealing again.
Yes. As Rachel Silverstein is quoted, their stance remains firm. The fight isn't about being anti-nuclear power per se, but is squarely focused on ensuring this plant can operate safely for its entire permitted life, especially an unprecedented 80-year life, and critically, that it absolutely does not jeopardize the drinking water supply that millions depend on. They are continuing to pursue all available legal and regulatory avenues to press these concerns.
This whole situation really highlights the incredibly complex tension at play here, doesn't it? You have the imperative for low-carbon energy sources to fight climate change, the reality of an aging national energy infrastructure, and the urgent need for environmental protection, especially water resources. And all of that is magnified by the undeniable impacts of climate change itself. It's a real-world, high-stakes example of this balancing act playing out right now.
It truly is, and the context, as you alluded to, extends way beyond just this one plant in South Florida. If you look broadly at nuclear power in the U.S., the material notes that the country still has the largest number of nuclear plants globally.
How many?
93 operating reactors currently, providing about 20% of the nation's total electricity, a significant chunk.
And most are old, right?
Yes, the vast majority of these plants were built before 1990, and as we mentioned, the average age across the fleet is now over 40 years old.
And there was that big slowdown in building new plants after the late 70s accident.
Correct. Construction of new nuclear facilities really slowed dramatically after the 1979 Three Mile Island accident. Public concern, regulatory changes, high costs. It all played a role.
Have many shut down.
Some older plants have been decommissioned and shut down permanently, yes, like the Indian Point plant near Manhattan. That was a notable closure. But currently, there's a strong, renewed interest in nuclear power.
Why the resurgence now?
It's largely driven by the urgent need for reliable, baseload, meaning always available, low-carbon energy to address climate change goals. Renewables like solar and wind are great, but they're intermittent. Nuclear provides steady power without carbon emissions. The material also mentions a specific growing demand coming from tech companies. They're seeking large, reliable, clean power sources for the incredibly energy-intensive data centers needed for things like artificial intelligence development.
Right, AI needs a ton of power. And there's even talk about changing regulations to make it easier or faster to build new nuclear plants.
Yes. The sources touch upon discussions happening within policy circles and the industry about potentially streamlining or overhauling the regulatory processes to try and accelerate the deployment of new nuclear technology, maybe smaller modular reactors or other advanced designs. So yeah, all of this frames the situation at Turkey Point as part of this much larger, really complicated national balancing act. How do we manage, upgrade, or eventually replace our aging critical energy infrastructure? How do we protect vulnerable environments like South Florida's water supply? And how do we simultaneously try to build out new low-carbon sources, perhaps including new nuclear, all in the face of these increasing climate challenges? It's a massive puzzle.
It really is. And just to put a finer point on the environmental stakes right there at Turkey Point,
Mm-hmm.
what specifically are the vital ecosystems located immediately around the plant, beyond just the human population and the aquifer below?
Oh, the immediate area is incredibly ecologically valuable and very sensitive. Just a few miles from the plant property line, literally next door, is the boundary of Biscayne National Park.
Biscayne National Park.
Yeah. This park protects a significant portion of the bay and its offshore waters. It supports incredibly diverse marine life. You've got dolphins, manatees, various species of fish that are vital for commercial and recreational fishing, like spiny lobster and bonefish. It has extensive coral reefs, vital coastal mangrove forests that protect the shoreline.
A really important marine area.
Absolutely. And it's also an area heavily used by people for recreation, boating, fishing, diving. It's a huge economic driver as well as an ecological treasure.
And what about to the west of the plant?
To the west, you have the vast expanse of Everglades National Park. This is a globally unique freshwater and brackish wetland ecosystem. It's home to iconic Florida wildlife like American alligators, the critically endangered Florida panther.
Wow, panthers nearby.
Yes, various smaller mammals too, like minks and gray foxes. And regrettably, the Everglades is also grappling with the huge challenge of invasive species like those giant Burmese pythons we hear about. So another incredibly sensitive and important ecosystem right there.
And the sources we looked at mentioned one particular species that seems to have found a rather unique, maybe unexpected, habitat right within the Turkey Point cooling canals themselves.
Ah, yes, that is a fascinating and perhaps surprising resident, the American crocodile.
Crocodiles in the cooling canals.
Yes. While American crocodiles are generally an endangered species, there is actually a thriving population living within the Turkey Point cooling canal system.
How many are we talking about?
Estimates suggest there are approximately 400 American crocodiles living and nesting within that 168-mile network of canals. FPL even has a dedicated wildlife biologist, Michael Loret, specifically tasked with monitoring this population.
400 crocodiles living in the cooling canals of a nuclear power plant. That's quite an image. And I imagine it sparks some interesting questions or maybe myths.
It certainly does, and Mike Loret, the biologist, is quoted directly on this. He takes pains to dispel a common, maybe slightly sensationalized myth you might hear. He states emphatically, quote, "No, they're normal crocodiles."
Okay, not radioactive mutant crocs then.
Definitely not. He counters any idea like that. He explains that American crocodiles actually prefer brackish water, that mix of fresh and salt, which is exactly what the cooling canals have become due to the evaporation and leakage issues.
So the water conditions suit them.
Apparently so.
Hmm.
And they may also favor the canals simply because it offers a relatively undisturbed habitat compared to other coastal areas in South Florida where human development has increasingly encroached upon their natural nesting and living territory. So less disturbance in the canals.
Normal crocodiles, just preferring the slightly salty, less disturbed environment of the canal system. It adds this incredible layer of biodiversity and ecological significance right on top of this major industrial facility and all the environmental challenges it presents.
It really does. And underneath all of this, the plant, the canals, the crocodiles, Biscayne National Park, the Everglades, the urban areas, is that fundamental, vast underground water reserve, the Biscayne Aquifer.
Which brings us right back full circle to why everything we've discussed today matters so profoundly, doesn't it?
Exactly. Protecting that underground water supply isn't just some abstract environmental goal or just a technical regulatory problem to be managed. As Rachel Silverstein of Miami Waterkeeper is quoted saying near the end of the materials,
What did she say?
it's directly about protecting all the interconnected life and resources that exist above that aquifer. It's about the sensitive ecosystems of the national parks, the remarkable wildlife like those crocodiles and panthers, the coastal mangroves, the marine habitats in the bay, and fundamentally, the millions of people who rely on that aquifer for their daily drinking water supply. Her quote really sticks with you. "This is just too important. We're not going to stop." It captures the determination of those advocating for its protection.
It really underscores the incredibly high stakes involved here. This discussion on meteorology matters has definitely shown us a situation where the need for energy, the reality of operating aging infrastructure, the significant environmental impacts of past and present decisions, and the accelerating risks posed by climate change are all deeply, deeply intertwined in a place that depends utterly on its water resources.
It's such a complex puzzle, isn't it? Balancing all these competing needs and pressures. And the outcome has very real, tangible impacts on something as essential as the water that comes out of your tap if you live down there.
Absolutely. So as we look ahead, especially as we consider nuclear power as a potentially vital part of a low-carbon energy future, this situation at Turkey Point leaves us with a significant, maybe provocative thought to ponder. Are we truly fully accounting for the intensifying risks that a changing climate poses to this kind of critical aging infrastructure today?
Yeah.
And how can we ensure the necessary safeguards, the planning, the investment truly keep pace with those escalating risks to protect both our energy supply and essential natural resources like drinking water?
It's a question that really needs to be central to these conversations about energy policy and environmental protection going forward, especially with infrastructure built decades ago, facing decades more operation.
Absolutely. And if you want to keep exploring how weather, climate, and the environment intercepts with the systems and places that shape our world, you should definitely follow meteorologist Rob Jones.
Where can people find him?
On Instagram, you can find him by searching for meteorologist, one word. On TikTok, his handle is TV Meteorologist, again, one word. And on YouTube, follow Rob Jones Hurricane. That's Rob Jones Hurricane, where you can also find the Meteorology Matters podcast playlist with more discussions like this one.
Great resources there, and thanks for joining us for this discussion today.
Thank you so much for listening to Meteorology Matters.